Hello guys, good evening. This is Dr. Pooja and I welcome you here to my another exciting session on a very basic and very important topic which you will be come across all throughout your life, okay? Because it is structure of atom, okay? So no matter in which grade you are, you need to understand what is the structure of atom, how does an atom look like, what are the main components of an atom, right? So in this session we will be, just a second, we'll be talking about structure of atom. All right, so before we get into the details of this lesson, I'll quickly introduce myself and I will also introduce like what we do on Unacademy's platform and how can you be part of our team if you want to learn from all the educators on Unacademy. All right, so my name is Dr. Pooja Sharma and I have done PhD in biotechnology and I was a scientist for 8 years and I was a lab director as well in the United States of America. Now I'm back here in India and I am an educator on Unacademy's platform. So guys, I teach you guys physics, chemistry and biology, everything for class 9 and class 10th, okay? So if you want to learn from me, go ahead and sign up today. And how to sign up on Unacademy? So we have this plus subscription which is super easy to get, which is super economical, which is super good because of these features. Because many people, they ask me, ma'am, we would like to be part of Unacademy's learners team, but we are not sure how to get ourselves enrolled for the same, okay? So what you have to do is, first of all, let's understand why you should go ahead and sign up for Unacademy. First thing, you don't have to go anywhere. You can learn from the comfort of your home. There is unlimited access to all the courses and we have educators from all over India for all the different subjects that they will be taking. They are the experts of their field, okay? Then what we do on this plus platform is we cover the syllabus, and not just we cover the syllabus, we have regular doubt clearing sessions on which you will be clarifying all your doubts. We have live test series where educators like me will be answering all your queries, all your questions on the test that you have taken a couple of days here and there. Okay, then if let's say you have missed the lecture, don't worry, we have study material saved for you in a PDF format. You can access it anytime. And then we have answer writing sessions and mentorship and guidance from the educators like me, okay? And here is my code, guys, if you would like to go ahead and sign up for any of these subscriptions that I will show you in a minute to get an extra 10% discount, then please use my code which is PS13. Please go ahead and use it, okay? Then we have there are different batches and they are both in Hindi and English, whatever your preferred languages. You can go ahead and sign up for the same. And apart from this, we have a monthly package, 6 months, 12 months, 24 months and 36 months, which means you can get subscription for and 48 months as well. Wow, that's exciting. So if you get it, and that is going to be like at a super economical price, because you use this code, you get extra 10% on this. And guys, it is not even 1,000 rupees per month. You look at this, and in this price you will be getting all the subjects covered, all the major subjects covered, like science, your English, your mathematics, any language, so all this is covered. So it's going to be a super deal if you can go ahead and you can subscribe to our new subscription plans on Unacademy. All right, so we have classes like all the different class is also available. So don't worry like you're not eligible for anything. We have 9th, 10th, 11th and 12th. Okay, so it's going to be good for you. So this is your K-12 subscription, details about the same. And yes, if you are ready, we will just talk about today's topic, which is structure of atom. I'm going to explain all the different models of atom. So yes, if you look at this picture, what do you see? What do you see? Charged here. But what is the purpose of showing you this picture? Okay, let's go to the next page and I will explain. So, hello Royal Sharma. So when we were talking about, when we were talking about matter around us, right? In that chapter, we talked about everything that we see around us is made up of particles. Then later, when we did more study on the same topic, then Dalton, he came into picture and he said, whatever we see around us is made up of atoms, right? Now, these atoms are indivisible. That is what many scientists said, and Dalton's postulates, they state the same, like atoms are indivisible. Indivisible means we cannot divide atom further. Okay, we cannot divide atom further. That was there. Okay, so the whole purpose of showing you this picture is to talk about, static charge. So now what is static charge and how you can get that, that theory picture. All right. So what happens is when you rub a comb or a balloon on your hair, what do you get? After some time, you bring that balloon closer to your hair, they will start, getting attracted towards the comb or balloon. So why is it so? Why is it so? Many of you will answer this is because of static charge. This is because of something got transferred from here to, let's say, balloon, and when we bring balloon closer to here, they get straightened out, right? So what got shifted? That means something got shifted, and whatever got shifted, that has some charge on it, right? So that charge we call static charge. Okay, so now because of that charge, we are getting that as I said, that attracted here towards comb or balloon. Okay, so now let me rub this off and I will explain a couple of more things. Okay, so now we know static charge is the word. Okay, now do we know like the atoms must be having some kind of charged particles? Because if they had all these charged particles, because of these charged particles only, there was that static charge. Okay, so now if we quickly talk about three scientists, J.J. Thomson, okay, and Goldstein, he discovered electrons and he discovered protons. Okay, let me take another marker. Okay, color, I will use a red color. So that means whatever particles we have, now we will conclude the atom is divisible. Means initially we said atom is non-divisible. Now we say atom can be divided into subatomic particles, right? Now we say atom can be divided into subatomic particles, and here we have named those subatomic particles as electrons and protons. So from this static charge wala experiment, we have concluded that atom is made up of some kind of charged particles, and when we rub these two things together, right, then these charged particles, they move from one object to another, and that is the reason of that static charge. Okay, so we got as I said, J.J. Thomson and we got Goldstein, and both of them, they came up with electrons and protons. And if you later on talk about Chadwick, he gave us neutrons. Okay, so now from here, when J.J. Thomson was working on his experiments, the particles that he found, which we call electrons, now he came up with an idea that these electrons, they have negative charge. Okay, and he gave us another particles, those protons, and those protons, they have positive charge, right? And neutrons, they are neutral. Now we got Roshan, we will talk about it in a minute. Okay, we'll talk about it in a minute. So we have electrons and protons, they have negative charge and they're positive charge. Now next question is, how are they arranged? Thank you, Sahil. In an atom, right? So that is our next question. Like now we know, okay, atom is divisible, atom is made up of electrons and protons and neutrons. But now next question is, how are they arranged in an atom? Okay, so that is our next question, and we will have our discussion around this topic. So here is a quick picture to show you guys like how we know today, like the atoms are what kind of structure they have. Now we know the atoms, they are made up of protons and neutrons, and they are present in the center, or we call it nucleus. Okay, and these two together, we call them nucleons as well. Okay, and all these electrons, they revolve, or they are moving around the nucleus, right? So this is the basic structure that we know. Okay, so now our next question is, what is the structure of atom? So that is our today's main topic. What is the structure of atom, right? How these, let me change the color, how these protons and electrons are arranged. Okay, so the first model that we got was J.J. Thomson's model. So we call J.J. Thomson's model as plum pudding model. Okay, and it is also called watermelon model. Okay, so as per this model, it is just like, if you see, look at this ball kind of thing, this green thing, Johnson said, J.J. Thomson said, like all the whatever, because at that time we were sure that we have positively charged particles and we have negatively charged particles. Okay, and J.J. Thomson said there is a big cloud of positively charged particles. You see, the positively charged particles, they are all spread over the place. Okay, so that is what he said, like positive charges are spread over the whole place. And just like watermelon, we have that red part of the watermelon as positive charge, and the black seeds are the negatively charged electrons. Okay, that is what J.J. Thomson gave us, like plum pudding model, just like the cake, and we have raisins in the cake, just like that, or just like we can also say watermelon model. Okay, so we had this model for some time because in science the research, it keeps on going on, and then we, new scientists come and they give us new idea, like how these things are arranged. So J.J. Thomson's model was the very initial, the first model. Though it told us like it is made up of plus and minus charge, and it said these charges are opposite, but they are same in magnitude. Same in magnitude means the number of plus charges is equal to the number of minus charges. Okay, so that means all in all the atom is neutral. Okay, so if somebody asks what was J.J. Thomson model was not an acceptable model, but what was the point that it clarified? So what we have to say is the neutrality of the atom was explained by J.J. Thomson's model. Why? Because that is the only point that it covered. It said the positive charge and the negative charge is just like the watermelon, but the charge is equal in magnitude. Means positive charge is same as we have the negative charge. Okay, so this is about J.J. Thomson model. And then after J.J. Thomson, we have Rutherford in picture. Okay, so Rutherford was the next scientist, and he was like, all right, Thomson, if you say like this is the model that we have for atom, but he said, I propose another model, which is he used those that gold foil model, we call it. Okay, experiment, that is what we call it. So what he did, okay, because now he wanted to explain how these electrons and protons and neutrons are arranged in an atom. Okay, so what he did, let's explain it. Let me take a so I will show you the pictures as well. So Rutherford model, so what it showed, first of all, what all he took. Number one, he took a thin gold foil, so the thickness is only 1000 atoms. Second, he took alpha particles. So alpha particles are helium nuclei. Okay, helium nuclei means it is only 2 positive charge nucleus of helium gas, which means it had these 2 protons and these two neutrons. Okay, so these two protons are there and two neutrons are there. So this is alpha particle. Okay, so this was Rutherford's alpha particle, and it had +2 charge on it. Okay, but it was heavy because it had proton and 2 protons and 2 neutrons. Okay, so what he did, he took thin gold foil, it's okay. So thin gold foil and alpha particles that we will be talking about in Rutherford's experiment. Okay, so if we go back here, give me a second. So here is Rutherford's model. So what he did, I will just show you the setup. So what he did, he took this alpha particles were coming out from this source. Here is the gold foil over here. Okay, and the alpha particles will come out, they will bombard the gold foil. Okay, and what he was expecting, as Thomson said, so this was Thomson's model. So this was the expectation, right? Because Thomson said all the positive charge is spread out in the whole atom, and these blue dots are the negative charge. Okay, so as per Thomson's model, all the rays should go forward. All the rays, I mean alpha particles, I'm sorry, right? As per Thomson's model, all the positive particles should pass through the atom, and it will give you image over here. You see, it will give you image over here. But what was the observed result? When he observed, what he saw, the images was over here, over here, over here, here, you know. So why was it like this? Why all the rays did not pass straight as Thomson said? Thomson said all the rays, I'm saying rays again and again, all the alpha particles as per Thomson's model, right, should pass straight, right? And as per what Rutherford observed, they were not all passing straight. Some of them made image on the side, some of them at the back. So what is the major reason behind this? Why is it happening? Technical gamer. Okay, so why is it happening? So this was explained by Rutherford as there were a couple of points that Rutherford made. One point, the first point Rutherford made was the positive charge is not spread out on the whole atom. Second, he said the positive charge is concentrated at one point in an atom, okay, and that is in the center of the atom. Okay, this is what Rutherford called later on nucleus, because he said as the whole positive charge is concentrated, so that means let's say this is an gold atom, right? And here is that nucleus that he's saying, like all the positive charge is concentrated in the center. And let's say this is the alpha particle. So alpha particle hit it and goes back. Okay, so that means this nucleus is having some kind of mass as well. So not only positive charge, but it has neutrons as well. Okay, I'm sorry. So nucleus has neutrons as well. So this was very well explained by Rutherford, that I will go back to that picture. Now see, this is the nucleus that Rutherford said, that positive charge is not spread out on the whole atom, and negative charge are not, spread out on this positive charge cloud. Okay, he said the positive charge is centered in the center of the atom. Okay, and negative charge, it revolves around the atom. Okay, now from here, so these were the positive points of Rutherford because it gave us the point. But now let's talk about what are the drawbacks of Rutherford model. Okay, now Rutherford's model was all talking about, this positive charge in the center, and he said the electrons, they revolve around the nucleus. Okay, that is what he said. Electrons, they revolve around the nucleus on a path which we call orbits. Okay, and now as they are moving on the orbits, these electrons are moving the orbits, they accelerate. And once they accelerate, they lose energy. And once they lose energy, a time will come when they fall in the nucleus. And the atom will collapse, and atom is unstable. But generally, this does not happen. Whatever elements we see around us, whatever things we see around us, they are pretty stable. Then what is this Rutherford talking about? All these electrons falling in. As per his, like let's say this is the positive charge nucleus, and he said electrons are revolving and revolving and revolving and revolving, and they fall in the nucleus ultimately. Okay, and then atom will disappear. But this is not happening, right? This is not happening. So this is not true. So Rutherford's model was not able to explain this point. Okay, and Rutherford's model was also let's talk about the other point. He was also not able to explain like how electrons revolve, means how many shells are there. Are there 1 shell, 2 shell, 3 shell, 10 shells? How many shells are there in which these electrons will be moving? This was not explained by Rutherford's model. Okay, so now we have another person, now we have another scientist which we call, let me erase this, Bohr. Okay, then Bohr said electrons are, hello Mohit Jindal, like electrons are revolving around the nucleus, and they are doing it in definite energy, I'm sorry, definite energy shells or levels. Okay, that is what Bohr said. Okay, now we have Bohr and Bury, and these guys gave us number of different energy levels, and we call it energy shells. Okay, so let's talk about these shells real quick. So they gave us this formula 2n square. Okay, so these are the number of electrons present in each shell. Okay, so 2n square is the formula that we will use to place electrons in an atom in the shells. Okay, and Bohr and Bury also gave us this thing. There are different let's say K shell, L shell, M shell, N shell. So these are the names of the shells. So if we write, so this is shell number 1, 2, 3 and 4. Okay, so these are the number of shells and how these electrons are present. If we use this formula of 2n square, okay, so for K shell, 2 will be, n will be 1 square. So the number of electrons will be 2. If we talk about L, it is 2 square, 8. Then we have M shell, 18. Okay, and if I say N shell, 32. So this is how the electrons, they are present in the shells around the nucleus. Okay, so now we will have, I will erase this all. Is all this clear to you? In the structure of atom, is this clear to you guys? Okay, so now next is, let's talk about what is atomic number and what is atomic mass, what is electronic configuration, and what is valency, right? So we will quickly talk about all these terms. Atomic number is represented by Z, and that is the number of electrons or the number of protons which are present in the atom, right? So when you see on the periodic table, you will see this value for each element. So what I say, these Z or Z is the atomic number. It is kind of like I card for that element. All the elements, they will have their unique value for Z. Okay, no two elements will have this same value for Z. No two elements in their neutral state, I would say. I'm not talking about ionic state. In their neutral state, the two elements will not have the same value of Z. They will have their unique value for Z. Okay. Roshan, I've already answered that question. If we go back, I've answered that question. An electron moves, and because when it moves, right, it is spinning around the nucleus. That nuclear force is also attracting it towards itself, and because it is spinning, it tries to move away, and this kind of forces, they are balancing out each other. So that is the reason the electrons, they move in discrete shells, discrete energy levels. Okay, they have their own energy level. They don't release energy when they are moving in their shells. Okay, so when we talk about atomic mass, we represent it by A. And atomic mass is what? Atomic mass is the number of protons plus, which is a positive charge, and number of neutrons, which is neutral in the atom, right? So protons and neutrons total will be the atomic mass, and it is represented by A. So now next important, these two are very important when we talk about, atomic number, and when we talk about like what is the electronic configuration of the atom and what is valency. Okay, so let's talk about electronic configuration, and let's talk about the valency of the atom real quick. So let me take a red marker. Sorry, I didn't change the color. Wait a second. Okay, so now we'll talk about, हाँ मेरी क्लास में मेरे YouTube सेशन में ज़्यादा बच्चे नहीं होते, तो don't worry. Okay, so now we'll have electronic configuration. Hello Madhav, how are you? So electronic configuration is how the electrons are arranged. We'll talk about that. That is the electronic configuration. Okay, so now let's start with, if we also know by now K, L, M and N shells. Okay, and we know how many electrons are present in each shell. K shell 2, 8, 18 and 32. So whenever we get the atomic number for any element, whenever we get the Z value for any element, we arrange those electrons in the atom, right, in the shells. Okay, so now let's take an example of lithium. For lithium, the atomic number is 3, and how would we arrange it? 2 and 1. So guys, when we are working with the electronic configuration, it is not, we have to always fill electrons in this order. Okay, we cannot fill like 8 electrons in first shell and then 2 electrons and then 18 electrons. This will be incorrect. You will have to start with 2, 8, 8, 18 in this order only, and you will not move on to the next shell until your internal shells or initial shells are full of electrons. Okay, now let's say we will take an example of sodium. Electronic configuration is 11. Here we have 2 electrons 8 electrons and 1 electron. And if we arrange it, like if we draw the atomic structure, here will be the nucleus, and here will be our K shell, L shell, and M shell. Okay, so we will arrange 2 electrons, 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8, and the outermost will be 1 electrons. Okay, so sodium has only 1 electron in the outermost shell, this electron over here. Okay, so what is valency? Now if we let's learn another term. What is valency? So valency is the electrons present in the outermost shell. They are called the valence electrons, right? They are called valence electrons. And let me see if I can add, let me add an empty slide over here so that I can, let me add a blank slide. Okay. Here is, so we will be talking about I'm sorry. We will be talking about valency. Okay, as I said, the number of electrons present in the outermost shell are called valence electrons, and they tell us whether the atom, it can lose electron, or it can gain electron, or it can share electron. So once we decide whether they can lose, gain, or share, because depending upon this they will make the bonding with other atoms, right? This is how they will make bonding with other elements. Okay, so let's take an example. So we had sodium, and let's take example of chlorine, and let's take example of carbon. Sodium, we know electronic configuration 11, chlorine atomic number 7, carbon atomic number 6. So if we go by this, it will have electrons 2, 8 and 1, because we have to make total 11. This will have 2, 8 and 7, and this will have 2 and 4. I'm going to talk about this lose, gain and share concept. Okay, so sodium is having 1 electron in the outermost shell. So by that, what do we mean? By donating this electron, it will have a stable configuration of 2 and 8, right? By donating this electron. Okay, so what it will do, it will tend to lose this electron, and if it loses this electron, it becomes positive charge, and once it becomes positive charge, we call it cation. Okay, and in this chlorine case, what is happening? The electron that is given away by sodium, this chlorine can take, because once it takes that electron, its this configuration will be 2, 8 and 8. That means chlorine, it gains electron, it becomes negative charge, and we call it anion. Okay guys, so this is the whole concept of valency, and this is the whole concept of making bonds. The valency for sodium is 1, valency for chlorine is also 1. Okay, because sodium is giving 1 electron, chlorine is gaining 1 electron. And what is about carbon then? Carbon has 6 electrons, 2 and 4. To complete its octet to 8, because it would also want to make this 4 8. To make it 8, it can either gain electron, it will not be, it cannot gain 4 electrons because that is too much. It cannot lose electron, which is also not possible. So what would carbon do? Carbon will go by the third path, which is what we call sharing of electrons. Okay, so now if we look closely at these two, so these bonds which are made by donating, or let's say losing, and gaining, let's say accepting of electrons, this kind of bonds are called ionic bonds, right? Because here ions are formed. Ions are formed, cation and anions are formed. Okay, so now let's talk about by sharing the carbon atom, it shares the electron. So the bonding, let me rub this off. So carbon atom makes bonding because it has electric configuration 6, 2 and 4. It can share these 4 electrons. When it shares these 4 electrons, the kind of bonding which is formed is called covalent bonding. Let's take an example of methane. Quickly I will explain. So we have carbon. It has 4 electrons, 1, 2, 3 and 4. And then we have hydrogen, 1, 2, 3. What other topic you want to discuss? Tell me. Mohit Jindal, if you want me to discuss any other topic, I can do that. So hydrogen is sharing these electrons. Hydrogen's outer shell is complete by having 2 electrons. Similarly, carbon is having 8 electrons. Okay. What kind of question is that, Mohit? How does it matter to you? If you want to ask any questions related to the topic, please do that. Otherwise, I'm not interested in answering any of your questions. Okay. So these are all. So carbon makes 4 covalent bonds. Right. So this is what we have learned from structure of atom. We talked about Thomson's model. We talked about Rutherford model. We talked about Bohr theory. And then we talked about what is valency, what is electronic configuration. Okay, so these are the topics that we discussed. So guys, if you have any questions from these 5 topics, you can ask me, and I'll be more than happy to answer the questions from these topics. And if not, I would love to, and yes, also we talked about atomic number Hello Ninja, atomic mass. Okay, so if you have any questions from all these topics, you can ask me, or else we can have a quick quiz, a quick question answer. Okay, Ninja, if you have any question related to the topic, then you can ask me here, and then if you don't have any, yes, I'm using Telegram, and let me share my Telegram link with you if you want, because hold on. Quickly, I will share my Telegram link, and you can use this Telegram link if you would love to, sign up for our batch courses. We take batch courses, we teach you guys science and all other subjects. So if you want to be part of our batch courses, just a second, I'm going to share the link, the Telegram link, and you will also get updates on any upcoming classes and all those things. So here is my I have shared, just a second, give me a second please. So here is Ninja, here is my okay, you can yes, I use my Telegram, but depends, like if you guys are asking me relevant questions, only then I'm active on my Telegram, otherwise I don't use it. Okay, but still, if you want to be part of our batch course, you can use my code PS13, and you will get an extra 10% discount on the same. Okay, and now we will have a quick poll session. Wait a second, why it's not working? So let's have a quick poll, and is it streaming or not? Okay, so yes, electrons were discovered by, so this is a very common question you get in your 1 marks MCQs. So electrons were discovered by J.J. Thomson or Goldstein or Chadwick or Rutherford. So the answer is they were discovered by J.J. Thomson. Okay, and there is another question as well. Who coined the term electron? So I mean, that is another important question that you can get on this topic. Then next is protons are discovered by Thomson, Goldstein, Chadwick, or Rutherford. You can take your time and then you can answer it accordingly. I'll give you a couple of seconds, and then you can answer who discovered protons. So if we talk about J.J. Thomson, he discovered electrons. Chadwick, he discovered neutrons. If we talk about Rutherford, he discovered nucleus. So Goldstein is the one who discovered our protons. Okay, so we move on to our next question. So neutrons were discovered by, so these discoveries are very important if we are attempting our MCQs, whether who discovered electron, proton, neutrons, and you will get 1 marks easily. So neutrons were discovered by, as I said, this is by electron, Goldstein proton. So neutrons were discovered by Chadwick. Hello Gurnur and Rutherford, he didn't discover these, right? So if we move on to the next one, nucleus was discovered by whom? Super easy, the electrons, Goldstein protons, Chadwick neutrons, and Rutherford discovered the nucleus. Okay, So now here is another very important question. What are alpha particles? We know that Rutherford in his experiment, he used the gold foil. If I quickly draw it, he used the gold foil, and these were the atoms present in gold foil, right? You will see this picture when we talk about Rutherford's model. I'm sorry, these gaps are not there, but my drawing is not that great here. So we have this nucleus. Okay, so the alpha particles, some of them moved straight, some of them hit back, some of them got deflected. So alpha particle is what? Is it a helium atom? Is it a hydrogen atom? Is it a helium nuclei or hydrogen nuclei? So alpha particles used by Rutherford were, as I showed you in a previous slide, it was a helium nuclei having 2 protons like this. I'll draw it for you. And 2 neutrons. That's okay, guys. You guys are just talking bullshit, which is okay, right? So alpha particle is helium nuclei, 2 protons present, 2 neutrons present, and it was having 2 positive charge on it. Okay. Okay. J.J. Thomson model was good to explain neutrality of the atom, presence of nucleus, presence of positive charge in the center, or none. So we know that J.J. Thomson model was, what was that? It was like plum pudding model. It said there's the positive charge everywhere, spread out. And in this model, he explained that negative charge is there. Right? So he said there is opposite charge, positive and negative charge present, but it is present in same magnitude. Same magnitude means positive and negative charges, they are present in same number. Okay, so that means if positive and negative charge is same, atom will be neutral, and this was the point explained by Thomson. Okay, so with this, guys, I will end today's session on structure of atom, and we have covered all the major points. And if you want to, as I said earlier, if you want to be part of our team, let me go quickly back to our original Unacademy's sheet, how you can subscribe. So here is the plan. You can follow this, any of these plan. Here are the 10 plus 1 and plus 2 subscriptions. Here are the subscription for all 4 years starting from 9th, 10th, 11th, 12th. And here are your whatever you want to choose from. You can go ahead and choose it, and it is, as I said earlier, it will be less than 900 rupees per month, even less than 1000 rupees. And when you use my code, which is PS13, you will get extra 10% discount. So if you want to avail all these offers, if you want to do that, go ahead and be part of our batch on Unacademy's platform, because we guys are the best in the market. Okay, so go ahead and join the team, and we'll be more than happy to have you in our batch courses. So with that said, I will end today's session, and I will be taking more sessions on this channel. If you would love to join, I have also shared my Telegram link in the chat box. You can go ahead and you can sign up for the same. Okay, so with that, I end this session here. You guys have a wonderful evening. You guys take care. Bye bye.